All right, let's get started. So this week is our last testing week. So like our other testing weeks, this will be a lot of live coding. And with other live coding lectures, feel free to ask questions, get off track and stuff. Though the last section didn't take me up on any of that. So if you don't, I have my things that I want to say, and I'll just go through that stuff. But if you do have questions, especially anything that'll help you on the homework, I'm going to go over things that I think will help you on the homework, go over some common issues and things that me and the TAs have seen. But if there's something that you think will help you better on the homework, or just how to help you become a better programmer in general, let me know, and I can show those things. I'm fine getting off topic when it's live coding. I might have a few slides on Wednesday. I'm leaning towards not, but if I have any slides, it'll be on Wednesday. Might just be live coding all week, so don't get excited to see slides pop up. Probably won't see any this week. Unless I get really ambitious and slap together probably like 5 slides or so that I would do on Wednesday before jumping into the code. But I might just jump right into the code. And application objective 1 is out. The grader isn't out yet. I'll hopefully be able to get that out tonight, but at the latest tomorrow, I'll get the grader out in Autolab. But you have the task, you can get started on it and get working on this assignment. Being a testing assignment, or at least with the structure of this one, I think the grader is less important, so hopefully that doesn't really hinder people having that no grader for half a day to a day. But that said, I still want to get it out as soon as I can. As long as I don't collapse after lectures today. I'm going to get it done tonight. So application task 1. For all the application tasks, the 3 application tasks, they're each going to be their own project with a new project to clone on GitHub. So tasks 1 through 9 were all one big project where everything came together in the end. For these ones, all separate ones, so there's new code. You can look at the code, and you have some starter code here. There are 2 application objectives available on each one of the AO tasks. So they're broken down into what you need to do for the first one, what you need to do for the second one. For the first one, there's no necessarily new concepts for this first one. It's going to follow the structure of what we're going to do today and Friday in lecture, where we're going to get broken code, and we have to test, debug, and fix it. So that's the goal of these first 2. So you have 2 methods. Standard deviation, which, as it implies, computes the standard deviation of an array list of values. And then find keys, which takes 2 hash maps and a value and returns all of the keys that map to that value in either of the hash maps and returns that in sorted order, in a sorted order, which is all described here. I won't just read the whole thing. But the idea is, the point is you have 2 methods, and these methods are already implemented in the repo, but they're wrong. They don't do what they're supposed to do. They both have at least one bug in them. Spoilers, like find keys has multiple bugs. Your task is to write tests to expose the bugs, and then go in and fix those bugs, fix the issues to get this code working the way it's supposed to work. Because right now the methods don't do what they're supposed to do, and they're made to be more obscure bugs that you're not going to just look at the methods and just say, oh, that's the issue, and then fix it. Maybe you can, and if you can, that's great. But the idea is that you'll get practice writing tests that expose bugs, and then using those tests and the debugger to eradicate those bugs and fix those bugs, which is exactly what we'll do in today and Friday's lecture. And I'll briefly go over the second one. This one we haven't talked about yet. This is Wednesday's content. But I think I mentioned it, but just to make sure. So you're ready to do these ones right now. You could do these ones even before today's lecture. Today's lecture and Friday's lecture, it's mostly like tips, tricks, common pitfalls, things like that. But you can very well do these, tackle these ones right now. The second application objective, not so much. I mean, I guess you could kind of figure out what testing with mocks is. But this one, we have code. Again, you have code that's provided to you. But this time the code actually works. It does everything it's supposed to do. And your task is to test that code. The problem is this code uses a database. It uses a MongoDB database server that it connects to get the job done. And you can if you want. If you're interested, you can spin up your own server. But the idea is that you won't spin up your own MongoDB server. There's nothing about databases in this course. I don't expect you to understand how to use databases, how to install them, run them, spin them up, connect to them, all that stuff. I don't expect you to do that. I don't expect you to go through that. But this code depends on a database, and we still want to test it. The code we want to test depends on a database. We want to make sure this code does what it's supposed to do, but we don't want to have to spin up a database server in order to test the code. So for that, we're going to use mocks. I'll save most of the conversation for Wednesday, but we're going to create a fake implementation of a database that isn't actually a database at all, and use that fake implementation called a mock for our testing purposes. So this is a common strategy when you have a large project with lots of dependencies, especially external dependencies. You have a database server that you're talking to. You have a web server listening for client connections. You have maybe several external APIs that you're connecting to. And when you want to test your code, you don't want to have to spin up all these other services and connect to outside services to be able to test your code. You just want to test your code independent of all the external dependencies. So what we do is mock out all those dependencies so we can just test our code. So that's what we'll see. That's what we'll talk about on Wednesday, testing with mocks. With that, let's get into it. Okay, any questions before we get into it? So what we want to do today and Friday, in the first lecture, we only got through 2 examples, and Paul only got through 2 examples, so probably examples 1 through 4 we'll get through in the 2 lectures, and 5 and 6 will just have to sit here. But we want to go through these examples. Each of these 6 examples contains code that has comments explaining what the code is supposed to do, but it doesn't do that. All 6 of these examples, they're all broken. So this is exactly what you want to do on your homework. You have 2 methods, and you want to write tests, find the bugs, fix the bugs. This is the same thing that we're going to do here. We have some broken code. We're going to write tests. Those tests are going to expose our bugs, and then we're going to use those tests, run the debugger, find exactly where the bug is, and fix it. That's our goal. And these bugs are, I go back and forth on this, and the last class was pretty silent. I feel like y'all will be pretty silent too, but I feel like the bugs are fairly easy to spot, at least this one is, but I might be completely off base on that one as well, so I'm not quite sure. But if you do want to let me know, tell me how easy or hard these ones are. Because writing these, I'm like, that's going to be too obvious. They're all just going to see it, and then they're not going to... Because the whole idea is that the bugs are hard to find, so you see the value of writing a test, and then the test exposes the bug, and then run the debugger to actually find it. So if they're too easy to spot, I have to make them harder to spot. Hard to spot, but easy to see in the debugger. That's what I want. So let's write some tests for the... Oh, I didn't even introduce the method. So this method is increasing. It's a static method, so we're going to call it through the class. And what this does, what it's supposed to do, is take an array list of integers and returns true if the integers are strictly increasing and false otherwise. So strictly increasing, meaning if we do have a tie, it should return false if 2 consecutive values are not strictly increasing. So let's write some test cases for this. Test increasing. Have my test annotation, and as I'm coding, I'll point out common things that I see, just tips, whatever as we go through. One, I'm not really seeing this one anymore. I think we're too late in the semester to benefit from this because none of you are making the mistake anymore. But forgetting your test annotation, if you forget your test annotation, that's a helper method. It's not a test. JUnit is not going to treat that as a test. In Autolab, it's not going to see that as a test. It's not going to run it as a test. And it's effectively like the test isn't there. So you have to have your test annotation to say this method is a test. Or else, if we didn't do that, if you say, well, why doesn't it just treat every method as a test? Well, then you can't write helper methods, because your helper methods would be treated as tests, and your helper methods are going to have parameters. So what are the parameters to a test? It would get dicey. So public void test test increasing. I'm not going to get too creative with my test names today. So we want some test cases to be able to test this method of test increasing dot. Test increasing is this class. I was wondering. Increasing check dot is increasing of input. So I did this in the same order last time. I code in the order that I think of things. I don't code in just order of the code. And I did it in the same order in the other lecture too. It must just be how I like writing this test. Boolean actual. So I know I need to call my method at some point. So I'm going to start with the method call. And that's going to be my actual. Then I know I need some test cases to actually populate this thing. This method, so I'll set up my test cases in different ways depending on what the method calls for, how it's structured. This one is a static method with clear input-output behavior with one parameter. That's just screaming hash map to me. I'm going to have hash map of inputs to outputs, and that'll be my my test cases. So this is array list of integer to Boolean. Test cases equals new hash map. Why did it? Oh, because I don't have this imported yet. Import hash map test cases dot put new array list arrays dot as list. Oh, autocomplete didn't work for me there. And my first test case, 1, 2, 3, is a good first test case for this. 1, 2, 3, it's strictly increasing. I expect that to return true. Let's hold off on more test cases so I can get rid of this error on input here. So for array list of integer input in test cases dot key set. Actual, and then my expected, Boolean expected equals test cases dot get of input. Assert equals, make sure expected is the same as actual. I'm going to put my star here. So I'm importing all the assert stuff so I can do assert equals, assert true, anything that I need. That star will just have me covered. So we have our test case set up. We can add test cases easily. I'm just going to copy and paste this. Add some more test cases. Let's get some negative values in there. Looks good to me. And that maps to true. It's still strictly increasing, so that should be true. And let's get one that's a false case. So if we have 1, 3, 2. Actually, don't want to do that. 3, 2, 1 should be false. So I got some test cases set up. I'm going to run my code. Now we know I already told you this solution is incorrect, so hopefully our tests fail. Oh, our tests fail. Assertion error expected to. So that is actually, I'm glad I made that mistake. This is a common mistake that does happen. I just hit the go button up here. This go button will run the last thing that you've ran. Last thing I ran was test cities in the previous lecture. So I didn't run the code that I'm looking at. This doesn't run the code that you're looking at in the editor. It's just the last thing you ran. So I'm going to make sure this code is ran. And I actually expected these to pass. So let's take a look. 1, 2, 3 is true. Oh, that should be a -1 there. I meant for that to be -1. But it's good. Our code did get rid of that one. So our code passes here. We know our code's broken because I said it's broken, right? But it passes these test cases. And this is something I'm still seeing a lot in office hours, Piazza, and everything. You code up these 3 test cases, you hit go, passes your code, and then you say, submit to Autolab, I'm done testing. Please break that habit. Please stop doing that. You write 3, these are decent test cases, but we haven't even thought about edge cases yet. We haven't done much testing. It's just 3 test cases that are pretty straightforward. These are straightforward test cases. Clearly didn't expose the bug in our code. But these 3 test cases, you write these 3 and you submit to Autolab, and then you say, Autolab says I'm passing incorrect solutions. What do I do? Write more tests. Just write more tests. Just sit down and write a lot of good tests. I can't express this enough. So what we're trying to get across with the testing is that you write unit tests for your code. You sit down, you write a lot of good tests that challenge your code. You think, how am I going to challenge my code to really test if my code is always returning the right thing? And everything you think of, ooh, this is a tricky one, this is a tricky one, is my code going to get this? And you do that and make sure your code passes all of those test cases, because then you gain confidence that your code is correct, that it is doing what it's supposed to be doing. It might not be 100%, you're not going to test every possible input, but you're gaining confidence that your code is actually correct. And that's a skill you're going to need to have. You yourself need to be able to decide if your code is right or not. Because in your career, after you graduate, and even in future CSE courses, but certainly by the time you graduate, you need that skill. You're not always going to have someone or something there to say, yeah, your code's right, to give you that pat on the back and say, you did do the right thing. You're not going to have that confirmation. You're going to release code to your users, and if it's not right, the product tanks. Your company goes down and bad things happen. You get a lot of bad reviews. You're not going to have somebody telling you whether it's right or wrong, except the end user. Ultimately, that's the person who's going to tell you that your code's wrong. You don't want to get in that situation where you're releasing buggy code. It obviously happens. We've all used buggy code. Don't let that be you. Don't be releasing code like that. So what habit you really should be developing is being confident that your code is correct before submitting to Autolab. Some of you are still submitting to Autolab, even on these later assignments. For Task 4, I kind of expected it. But for these later assignments, still submitting over 100 times on a single task. You're not learning when you're doing that. You're just guessing, checking. No company is going to pay you $100,000, 6-figure salary to be a guess and check machine. And what are you even going to do? Write one line of code and go back to your supervisor, go back to your senior dev, hey, is this right now? Change a line of code, is this right now? You can't do that. You're not furthering yourselves. You're not developing yourselves as a programmer. You're not getting better at your skills. You're just trying to brute force through an assignment, which is just going to make the next assignment even harder because you didn't internalize the lesson that we were doing in each one of these. Testing is a major part of that. Being able to test so you yourself can be confident that your code is correct without anybody telling you whether it's right or wrong. That's where you need to be by the time you graduate. So we're trying to do that in 116. And this is, some of you will rejoice to this, but this is like the only course, I think it is the only course that requires testing. Beyond 116, you're just expected to be testing your own code. And a lot of students don't, and a lot of students, unfortunately, fail to 2250 because they don't internalize that lesson. They're just used to bashing against the autograder. So anyway, we're going to sit down and actually write some good tests for this. And we'll write a few more anyway. We're not going to go all the way to good tests because I want to drip feed this one a little bit. But there's one clear test case that we don't have. Right in the description of the method, it says returns true if it's strictly increasing. So our very first edge case we need, not even really an edge case, but testing a feature, is 2 consecutive values that are not strictly increasing but are not decreasing. So the decreasing one is easy to spot. But let's get two that are consecutive values that are non-decreasing, having the same value, and see if our code passes that, which it wasn't supposed to. That's increasing. Let me make sure my imports are right. I run the wrong thing again. Did I unbreak the code? Yeah, I did. Well, makes it less fun. I fixed the code in the last lecture and I forgot to re-break it, but well. Let me look at this for a second. If the first value is, no, wait, that should have. So I like so this is the perfect lecture for things to go wrong on because you get to see my debugging process. So it's a more authentic choice, more authentic experience. So I wrote these so I know what the bugs are, which is kind of cheating, but I didn't tell Paul what all the bugs are. I just said, here's 6 examples of broken code. So he got the authentic experience. So you get a little bit of it here too. So I have, this should return false. Oh, it's because it's just completely ass broken. I want this to be increasing for the most part, except for that one. And then run this. Right, and if this is strictly greater than, yeah, there we go. Because that was completely broken. Okay. So, and then I fail on this test case. So let's actually, because now I'm losing confidence. Let's make sure we're passing these 3 test cases. Okay. So, and that's a common thing to do as well. So you can have your hint text here. I kind of stopped doing hint text a while ago because, to be honest, I don't use it that much. It's very helpful to use until you know the debugger. You know the debugger exists. So I used some hint text until I started talking debugger. And now I expect you to use the debugger. So I want to set a breakpoint and run it on just this test case. First, I commented out this test case, so I know this is the one test case that's failing. So I'm narrowing down what I'm looking for. So I know I don't want to look at any of these 3 test cases. I want this one, and I want to run the debugger on this test case. There's a few options for that. You can just comment out the other ones and get that test case. Or just run your debugger and step through until you get to that test case. Now, this is a hash map. Remember, order doesn't matter in a hash map. So I'm not going to get these test cases in this order. I can't just shove this one to the top and then call it good. There's a way. I think I will show a way to do that. But what I would do is set my breakpoint right where on actual. I want to set it right before the method is called. When you set a breakpoint, the debugger stops at the breakpoint, but it stops before the line of the breakpoint is executed. So I'm putting the breakpoint right on the line where I suspect the bug starts. So I'm setting my breakpoint right before is increasing starts. Hit the debug button. I'm going to check what test case I'm on. So input 1, 2, 3. I know that one's passing. So I'm going to use the resume button. This is going to run the debugger until it hits another breakpoint. So it's going to go through this whole loop, skip all this stuff, and just go to the next test case. Next test case, 3, 2, 1. We know that one's passing. We know this one's passing. And then the 4th one, I noticed that wasn't in order. I think, was this one first? This, then this? But we're not going to get the order unless we just by chance happen to get the same order. We're not going to get the same order in that we inserted them. So we have this test case. Now I want to step through the method, and I want to check which pairs of values we're comparing. So I have this array list. I is 1. I'm going to get the value at I minus 1, which is the first value. I'm getting 1 as expected. I'm going to get the value at I, which is 1. I get that value as expected. So the first comparison I'm making is between the first two numbers. Is the first number strictly greater than the next one? If it is, then I want to return false because we're done. We're not increasing at that point. This is false, so we're going to skip the return false. We're going to get the next pair of values. Looks like my code's doing what it's supposed to. It's moving on to the next pair. 2 and 2. 2 greater than 2 is false. So we're going to skip the conditional, not return false, but that's where I would have expected my method to return false. When 2 is greater than 2, 2 is the same as 2, it's not strictly increasing. My stuff's broken at that point, so I need to fix that one. So this comparison, which this one I assume is easy to spot, and nobody just wants to say anything, but I need strictly increasing. So if first is greater than or equal to the second, then return false. Or I tried to make this unreadable to an extent. What I would actually do, if I were coding this, I would make my code more legible and say if first is, actually I would probably reorder this. If second So make this more of a positive check. So this is what I want. I want second to be strictly greater than first. And if it's not, return false. So do the check that I want to happen, and if that check doesn't occur, return false. If we make it through all the checks without ever hitting that, return true. So let me stop the debugger, rerun this, and see if that fixed the bug. Hey, fixed the bug. And we have 4 test cases. We're passing our test cases. We're ready to submit to Autolab and make an angry Piazza post if it doesn't give me points, right? That's what we're going to do. And hopefully my tone gives it away that there's another bug in here. So what else do we need to test? What else should we be testing? We want to think about the edge cases. We want to think about common cases, uncommon cases. And let me pull up the code. What else do we want to check here? Yeah.
Are we testing through the entirety of the list?
Are we testing through the entirety of the list? Why don't you give me a test case of what you mean?
Let's do 1, 2, 3, 4, 3.
And do you expect that? Oh, false. Yeah, we expect that to return false. Okay, I like that one. So, are any other test cases? I'll hold off on running this. But are there any other test cases that we can think of? Yeah.
If the array list is null.
If the array list is, well, that one's actually going to break my code. Yes, of course. So, null, which I will have to update the code. I don't know what we'd expect to return. True or false do you want to return if it's null? False. Sounds good. Okay. That one, let's go fix the code right there, right now. If numbers equal null, return false. All right, what else do we want to test? I think an empty array list. I guess we don't need the arrays as list here. Actually, I think an empty array list it's increasing. There's nothing to break that. An array list of size 1, that's going to be increasing. And the big thing with this, what we want to check when it comes to get to the point here, the big thing we want to check with data structures like this, with our sequential data structures that we were missing before, is checking the endpoints. This is the common mistake. We see this all semester, every semester. Not checking the endpoints. Specifically with linked lists, it's more common that y'all don't check the endpoints of your linked list. Like getting to the, not y'all, but like it's a fairly common mistake to make. When you get to the last element of a linked list and you say if next equals null, then we're done. But you never check the value of the last node. Very common mistake, which is just part of learning linked lists and getting practice with linked lists. So there's nothing wrong with making that mistake. but it is a common thing to check. But the more general concept that we want to get out of that is that we need to check the endpoints of our data structures. So we have a case where, actually I would like another case like this. Let's break this let's just put it back to the way we had it before. Let's get a mistake somewhere in the middle, but some mistake in the middle should be caught. Like, it's kind of hard to have that bug unless your method is just completely broken. But the edge cases, we want to check. What happens when there's an issue at the ends? Here's an issue at the front end of the data structure. And what happens if we have an issue at the back end? What happens if we have an issue at the front end with the first two elements? And what happens when we have an issue at the back end with the last two elements? Because these are easy mistakes to make. These are mistakes that need to be tested. So thinking of our edge cases, our edge cases are the literal edges of the data structure in this case, and including our empty size 1 null. I usually don't handle null in homework assignments. If you're doing null checks in homeworks, I probably should start adding those. And let's run this, and hopefully we expose the last bug. Oh, spoilers, there's one more bug. All right. So we failed. And here we want to check which one failed. There's some options we can do this with. Let me just choose one. I'm going to run the debugger. I'm going to look at the test case and click Go. If we ever hit a test case where we crash, then we know that one's a problem. 3, 2, 1, looks like we're getting all these. An empty array list, looks like we got that one. Array list of size 5, 1, 2, 3, 4, 3. And that one gave us an assertion error. So we know which test case we want to look at. It's this guy right here. I'm going to comment that out. I like to get as much information as I can before diving deep with the debugger. I'm going to run this again and see if we have another test case failing. Looks like we do. So let's run the debugger again. Size 1, passing, passing, passing. Size 5, 100, 1, 2, 3, 4. Failed. It's because I didn't change this to false. That's a bug in the test. And then the rest of them pass. So we know this is the problem one. Let's run the debugger again, get to that test case. Oh, you know what? I did say I would show you how to get test cases in order. So if this is the test case, let's put this at the top. Order doesn't matter in a hash map. I do say order doesn't matter in key value stores in general. That's a little bit of a lie. If we use the map interface, so this is one reason how it's when it's nice to code to an interface. I can use any implementation that implements the map interface. So this code works just the same. I'm using my hash map, and everything works perfectly the same. Hash map implements map, so I'm allowed to do this. But if I want to change my map to, say, a tree map, which also implements the... Oh, why am I getting an issue? Ooh, yeah. No, I can't show you this today. Because it doesn't know how to sort array lists. Hey, isn't that... I don't want to go down this road now. A linked hash map? No, never mind. We're not going down that road. Because a tree map isn't going to work with array lists. I guess I've never used one with an array list. All right, so let's not do that. Let's just run the debugger. Oh, it was already running, wasn't it? No, it wasn't. Get to that test case. It was size 5. Here it is. And then let's get into our method and run this with our test case of size 5. Not null. We're going to get our first two values, 1 and 2. We're going to check 1 and 2. We fixed our Boolean, our conditional is fine. That's not going to return false. 2 and 3, we're checking the next two values. Looks like we're doing what we're supposed to. 3 and 4, looks fine, and then it just ends. Okay, so I can see the bug. We were supposed to fail when we checked 4, 3, but we never got there. We never checked that. So let's rerun the debugger again. Let's get to, I don't have to get all the way to that one. Actually, let's do it. Let's get all the way to that one. Doesn't take too long. So when we're comparing 3 and 4, the next thing that we expect to happen is to compare 4 and 3. So let's take a look at what's happening in our code. Let's read our code, trace through it a little bit to figure out what's going wrong, and using the debugger information to shortcut our trace. I'm not going to trace this all the way from the beginning of my test case. I'm getting partial trace from my debugger, and then I'm just going to figure out what the next click, something bad happens. Let's see what that is. So I is 3. We're going to increment I to 4. 4 less than numbers.size, which is 5, minus 1. 4 less than 4, loop exits, and we don't get any check. So this one may or may not have been obvious. Depends how much you paid attention on Friday, because I mentioned pretty much this exact bug. I set it up just a little bit different. But we have a situation where we're iterating over 2 values in an array list at all time at each iteration. So we have to set up our array list a bit differently. And when we're breaking the norms, when we're not just I less than size, it's easy to make some mistakes like this. It's easy to have these off by 1 errors. And that's why we want to check the endpoints of our data structure, especially in this case, because it's easy to miss those and have our checks not go all the way to the end of the data structure. So we either want I less than the size or I less than or equal to the size minus 1. We can't have both. So let's get rid of one of them. Let's change, I don't know, this one to equal. Actually, that's gross. Well, it's fine. Let's change this one to equal. And now we're going to check all of the pairs of values in our data structure. That's something that can be very hard to spot. If you're just staring at this code, trying to figure out if you're hitting every pair, it could take a while. It can take a while to see that. But the debugger, you step through the debugger, and the debugger basically screams at you and hits you over the head with it and says, hey, you never checked the last 2 values. Fix your code. Debugger is going to find that in one run of the debugger. We didn't even have to do the test case that's failing. We could have used any test case. Like if we did the test case with just one... it fails there. But if we do the test case of just one value, the array list has size 1, or no, size 2. All the way up to size 2, the loop never does anything. The loop never executes. I equals 1, 1 less than 1 minus 1. It's going to be false. Loop never executes until you have 3 elements. It's going to check the first 2. So very broken code, but in a subtle enough way that can take hours and an office hour visit to spot sometimes. Or you run the debugger once, 5 to 10 minutes, and you're done. You can find the bug and fix it. Run our tests. Tests. Feeling good. We wrote tests. We could always have more tests. More tests never hurt, but this is a pretty good test suite. We get all the common, uncommon cases. Our common cases, just a straight up 1, 2, 3. Our more uncommon, mixing in negatives and large numbers and stuff. Our edge cases, and then checking our actual edges of our data structure. We could add more variants. I would want more if I'm releasing this code to production, but this is a pretty good test suite that's got a good, not a tremendous abundance of tests, but a good variety of tests. You want a variety of tests that are all checking something else. Okay, any questions on this example? I thought we'd get through 3 of these each lecture, but I got so much to say about each one. Doesn't quite happen that way. All right, yeah.
Are any other edges in
Depends on the data structure, I guess. For a tree, like we're not going to get to this example So I'll talk about trees a little bit. Each node in a tree can be one of four different situations. Either has no child, just a left child, or just a right child, or two child nodes. So making sure that you're hitting all four of those cases as well with your test cases. So this code, I can just spoil the whole thing unless if you want a challenge and you want to go in here and get some practice, don't listen for a second. But this is only checking if it has no child node. So if it's a leaf node, then we're done with the recursion. If it's not a leaf node, we're going to go left and right. So if it has just a left or just a right child, this code is going to break. So the edges of a tree, since it's a non-linear data structure, get a little dicey. You have to make sure you're checking those four cases. I would have a tree that hits all four of those cases in probably multiple ways, multiple times, to really test a tree method. And my goodness, when there were trees, well, I didn't make you test trees, right? I forget exactly how that worked, but whenever there's tree code involved, I feel like I didn't have you make the trees, right? You did the playlist and added songs and then checked the linked list that's returned. Because generating test cases where you have to build your trees gets annoying. I spared you from that, but that meant you had more bugs in your tree code because you weren't thinking of those edge cases. I've seen test suites for that method where all the songs were added in alphabetical order and then testing your code that way. Well, it's a linked list at that point. You're not testing the actual tree functionality. But we won't be able to get to that one. We're also done with trees for the semester, so it's fine, I guess. So this code we're revisiting. We actually saw this code before. It might be a little different, and of course it has a bug introduced in it, so it's a little different in that sense. But just a refresher on what this is. We're calculating the population of a country, given the file name of all the country data and the country code. We're going to loop through all of the values in this hash map of country code to array list of cities and sum up the population of each city in that country. And we have a method that's going to read all of our countries. Oh, I lost my line. Grab Abu Dhabi. I like to paste the line so I can reference the data right here. This load countries is going to read a file in this format. It's going to ignore the header line, split on commas, and get the country code as the first split, the name of the country as the second split, the region as the third, then population as an int, and lat long as doubles. And we're going to create a location object. When I showed this code last time, I just had two doubles in the constructor of the city. In the repo, it was a location object, so we're using the location object. Throw all that stuff in the city constructor, and then lazily initialize our countries in the hash map. If we haven't seen this country before, initialize it to a new array list, and then whether we've initialized it or not, add this city to that country in the hash map. Then we had a helper method to read the file. We had our location class, which is just lat long. We have our city class, which is our name, region, country, population, and location values. And then we already wrote the tests. It took a long time to write these tests in lecture. I don't want to take all that time again, so I'm just using the same test. We wrote some code to find small cities and then use those as our test cases. We generated these test files, making sure we're reading the cities properly. Like this test, cities test 2 had these 4 cities. So when we run that code, we're expecting, We're expecting those 4 cities across those 2 countries. And then we calculated the population of a small city using the entire data set. This country had just a handful of cities, and its population was quad 8s. So we run these tests. It's when the internet cuts out. And it's failing. Everything's failing, and we panic and say, well, Actual was 0 instead of 8888. So something's definitely going wrong, and it's going wrong with all of our methods. So it's not just the population method, but even just reading the cities from a file. So what I like to do, still have my breakpoint set right there, is set my breakpoint. So right here, I don't really know what to think yet. My actual has 4 values. I know my file has 4 cities. So like each city is being treated as a separate country maybe, because I don't have 2 countries, I have 4, which seems weird. Oh, I didn't click on the thing yet. So this is the assert that's failing. The size of the hash maps are different. So I actually got 4 instead of 2. So I have more key value pairs in my hash map than I expect. So what I like to do, I don't have much information to go off of there. The hash maps are the wrong size. There are a multitude of different reasons why that could be the case. So I'm going to set a breakpoint right before my check, right before I go into my asserts, and then take a look at what actual and expected are. This is where you could use hint text, but the hint text really gets cumbersome at this point. You're going to print out an entire hash map containing a whole country full of cities, several countries full of cities. I'm going to look at that in my debugger because it's going to give me a much easier way to view all of that information. So I have all this. Oh, I don't want that breakpoint. So I have all this information in actual and expected, and this is where, like, eyeballing this error, just scrolling through code and trying to find this error could be kind of a nightmare. I showed the code. It went too quick to really get a chance to spot it, but you run the debugger and expand this in the debugger, I think it just jumps right out. It just leaps out of what the issue is. So if I look at my actual and I expand one of these cities, and I do this in office hours fairly often. Somebody will have an issue. I'll say, what does the debugger say? Set a breakpoint, and then I just click a few arrows like this, and then they say, oh, wait, that's not supposed to be like that. And then I say, well, there's your bug. You know what to fix. So when I expand this, I have my actual size 4 has a key Gibraltar mapping to a city with name, country, region, population, location. I have a country mapping to cities. Do we see the issue here? This is a common thing that we're seeing in office hours quite a bit with the songs. The name is not what we expect it to be. The country code is this 2-digit thing. That should be the country. The name should be Gibraltar in this case. So what